So this is the question which we are asked in the spring arrangement shown system. This is shown here. So the displacement x is caused by the applied force. So this force is being applied in this direction to this plate, and this causes the spring deflection. Assuming the system is in a static equilibrium, sketch the plot of force versus x. So we have to plot the force versus x. So if I draw, this is my x-axis, this is my force axis, and determine the equivalent spring stiffness for this arrangement where F equals to, the formula for the spring force is K equivalent X. So as you can see, these two springs, this spring number 1 and spring number 1, they are in parallel. So the parallel combination is that combination in which the spring is deflected with the same displacement if they are connected in parallel. If they are in series, the deflection is not the same. For example, this spring and this spring, and if you pull these two springs, so the deflections between the spring 1 and spring 2, they are not the same. This is the series combination. And in this case, so the spring deflection is the same, so this x deflection is the same. So what will happen in that case, when the springs are connected in parallel, the stiffness, this doubles up. If there are two springs, the stiffness becomes 2 times K1 times x. Okay, now this is my, so if I draw the line, suppose this is my line here, so the slope is this one. Okay, this is my slope. Okay, now so I can write it down here. So as soon as this plate touches this third spring, which is actually the K2, because the third spring has the new stiffness. Two springs both are having the same stiffnesses, like K1 and in this one. And now when it touches the third spring, this is another spring added in parallel combination. So when you see this plate, so let me redraw it nicely. So if I redraw this nicely here, so if this is, suppose this is a plate, and then if I draw 3 springs, 1, 2, 3, and then they are connected in parallel combination. This is K1, this is K2, this is K1 again. So you are pushing this plate downward, and the deflection is same for in every spring with the same amount of force. So what will happen then? F equals to K1 plus K2. The spring stiffnesses are added up. Agreed? And then what will happen? This is my new K equivalent. So I can rewrite here 2K1 plus K2. So this is my 2K1 is the initial slope, but now the slope is a little bit higher because you are adding up another parameter here. Do you guys understand this? So this is how you compare. Let me stop.